Hello everyone and Professor, welcome to our ICS final project presentation. This is Steve Lu and Kaylee Xu. We will present you with an impressive chat system with various features. We will first provide a brief introduction and then showcase our model, then go through our codes and finally talk about the potential improvements in the future. First of all, the introduction. The definition of this project is a GUI-based chat system with secure messaging and a built-in online game, Wenbo Lu, also called wl2707 in Chinese. Our main motivation is to provide user-centered design. Thus, we improved a lot about the graphic user interface, which is highly user-friendly, and we guaranteed users' chatting security and privacy. Finally, we added a game to enhance users' fun and pleasure while using our chat system. First, I will introduce the GUI functions, which includes the login and sign up windows. For those who comes to our chat system for the first time, they need to sign up and create an account. Otherwise, they can just directly log in. The major function is the chat and emoji. After login, users can connect other online users and send messages with 20 available emojis. Finally, to make it more fun, users can trigger the built-in minigame in the chat box interface.
Is a form of communication that ensures the confidentiality and integrity of the messages being exchanged between two or more parties. In the digital age, the security matters a lot. A single leakage of information could bring to the death of thousands or the fall of a superstar. Various encrypting algorithms are available, and here we choose RSA. RSA is an asymmetric encryption method that utilizes big prime numbers and power modulo operations to generate a pair of private and public keys. Senders encrypt the messages with public key and the receivers decrypt it with their private keys. This is made possible by mathematics properties and made hard to attack thanks to the impossibility to decompose large numbers. And here we try to implement without using third parties' libraries. It's a bit challenging, but also rewarding. For the game, we try to implement a 5 in a row, or known as Wenbo Lu. We add additional features such as runtime counting down, and after that, auto chat placement function.
So now we are going to show our demo. As a user who has not signed up in our chat system, he cannot directly log in with this error message. So if he click the sign up button and type in the username and password, if he type in the confirmed password wrongly, the system will show this error message to ask him to retype. So we just change this as the same as the password and then sign up. So the system will show sign up succeed, automatically sign you in. This is a feature that we think can enhance the user experience because the user don't need to get back to the login window. After login, the user will see this interface. And if we log another user in, so here, if we log another user in, there will be two online users and they can connect with each other. So now the connection is successful and they can chat freely, like send a hello. And one way is to click the send button here, but the other way is to press the return key on your keyboard to send this message. And you can reply with an emoji. Yes, that's basically how the chat system looks like. And we also have some buttons down here. One is the buy button. You can click it and disconnect with your peer. And also you can click game to trigger our mini game. Finally, you can click the quit to quit the whole system.
Okay, so here's the demo for our secure messaging as well as our online game. You may find the interface a little bit different because now we are presenting it on a Windows computer, but it doesn't matter. So after connected to your peer, you can send out a message, say hello, and press your enter key. Okay, now goes the message. You may wonder what's going on behind the stage, and you will find the message being sent out on the client side. And on the server side, the message will be delivered towards the receiver, not as explicit message, but a long code of after encryption. And also on the receiver side, it will be called the decrypt function here in the secure messaging to make it a string. Finally, the string the human can read. Well, that's all for the secure messaging, and you may wonder what's the game like. So simply clicking the game button, you will start a game on 2 different machines. And after the first player presses down first chess, the game officially starts. When the time runs out, but no action is being made, the computer will automatically place the chess for the player. And for the round the player is playing, his opponent cannot make the move before him, right? That makes perfect sense. So he cannot press it down here, only here. Well, a quick game. Let's make it quick. Let's make it quick. Let's make it quick. Right. So now you see one's winning.
Now we are going to discuss how these functions are realized technically. First, the sign-up window is composed of 3 pairs of label and entry, plus a button. To lay out this window, we use label and button functions and adjusted the relative width, height, and relative X and Y positions. After clicking the button, the sign-up action would take place. After checking the user is not in all user list, it will create a new account. And we did a small but important change, that is to automatically sign the new user in, instead of turning the user back to the login window and enter the username plus password again. This will largely increase user experience. The login window has a similar layout method, and we changed the text color of login to green to better highlight it. The login function will trigger a go-ahead function and show the user interface. We also add a feature that users can use the return key on their keyboard to log in by adding 1 line of code. This conforms to users' habits. Then, once the user logged in, he or she will see this interface, with a headline showing whose chat room and a separate chatting space in the middle. We define 2 checkbox configurations. This is to mock the widely used social media such as WeChat and Instagram, to provide a more real chatting experience. The messages sent by me will appear in the right side box, controlled by the send button function, and the messages from my peer will appear in the left, controlled by the proc function. Below the chat space, there are a bunch of emojis and texting box with a send button on the right side. We search the Unicodes of emojis online and choose some of them as representatives, and also change the send button to green as highlighted. For the send button, we also enable it with the return key. At the bottom of this interface, we added 3 buttons to replace sending messages to trigger functions. The buy button is to leave the chatting peer, the game button triggers Gomoku, and the quit button quit the whole system.
And here's the part of our secure messaging. So as we introduced previously, RSA encryption works basically on large prime numbers and also modulo operations. So these 2 operations become essential to implement the RSA algorithm. So first of all is about prime numbers generation. We first use random get_rand bits to generate 2 to the power 10 bits long integer and perform a bitwise operation, or 1, to make sure that the number is an odd. And secondly, we call this isPrime function, which utilizes the Miller-Rabin primality test algorithm to test if the number generated is prime. Well, now you may then ask, why this algorithm is timely, efficient, or feasible to use. This is granted by mathematic properties. Given the approximated number of primes smaller than the x, we can evaluate the density of prime numbers in a given number range. And we found that between 2 to the power 10 minus 1 to 2 to the power 10, the density of prime numbers is around 0.14%. And if we repeated the process for 10,000 times, the possibility for us to get a prime number is approximated 99.9999%, which is a pretty significant possibility. And in terms of the power modulo function, the performance also matters, and we'll leave this part of the discussion to the analysis. And a simple demo of the cryptographic strength of RSA, that with the best general number VOC algorithm with the strongest supercomputer available right now, it still takes around 60,000 years to decrypt a single RSA encryption. And here's the part with our online gaming. Here, what I've shown is the main game method, which shows how the game runs. First of all, a screen will cover previous pictures, and then we try to see if the user want to quit. Following that, a visual layout chessboard is updated, and also with a counting down timer. Finally, we will have the running out of time situation, where time runs out and the computer needs to put on the chess for the gamer. And finally, we have the game user interaction for users to put down their chess. And first, we have the visual layout function or method down here. So we can see we decompose the function to several components, which are draw the board and draw the grids. Following is the start points, and finally we have to display the chessboard. And what we are really proud of is the put down chess function, that we made out the best way to represent our chess, which is to use a nested list in the format of X location, Y location, and chess color. This is designed specifically for easy rendering, and is made possible thanks to the particular mechanism that we designed in report cursor method. And in the following green box, you can see the delay flag, which is a simple delay to avoid situation like you have only one click, but multiple chesses are put down onto the chessboard. This is not what we want. So this is the report cursor. It snaps the cursor to the nearest grid with its absolute X and Y location. And here we validate if the slot is occupied. If it is not occupied, in the chess guider function, it will automatically renders a semi-transparent chess on the chessboard as a user-friendly visual guide for the user to know that here is the place that he or she can put on a chess. Wow. And another magnificent features that we found really great is how we optimize the wing pattern checking. Compared to conventional wing checking method, which check every slot and perform check operation along 4 different directions separately, which generally takes a big O of n square time complexity and around 4,500 operations per update. By using bitboard operation, we simplify it to only 600 operations per update. And this is made possible by using the bitboard representation of the chessboard. We compress the 2D array, 2-dimensional array, into a 1-dimensional bitwise bit integer. As you can see in the code, it's following like 001110 stuff. And for the place is represented by 1 means that there is a chess over there, and 0 means there's no. And for the function to check if we have 1, it performs a shift left operation as well as a bitwise AND operation to see if we have the matching pattern, like represented here by the 5 consecutive white 1. And eventually, if there is a winning pattern, that we will reach an AND 1 situation, and it will tell that the white has won the game.
And to develop this chat system better, we have some potential improvements. Firstly, we can make sure the new message is below the last message, no matter it's from peer or self-sent. And we can also create an emoji button, which triggers a drop-down menu containing all the emojis. And we also make sure users can quit the game and get back to the chat box. And finally, we can add a group chat function.
And finally, in terms of the power modulo optimization, we try to do a little bit better than the built-in function, but it turned out that the written in C built-in function is still more efficient than the Python code that we wrote. So yeah, that's it. And thank you for listening. 这说了多长？